keep coming and checking, stamping for homework. First 3 pages of Unit 11. Once you have your circle cut out, you need to fold it. I don't know if you can see it on this picture, but fold it in half, fold it into fours, creating 2 diameters that intersect. By seeing that intersection, we know where the center is. So you need to go ahead and add that point to indicate your center of your circle. Okay? And then once you are ready, and I'll play this video while you kind of get up to date, you're going to use your pipe cleaner to measure your radius. So you're literally going to end up drawing out the radius here. Okay? Actually trace it on your crease that you made when you fold your circle. And then line up your pipe cleaner so that you can have that to represent the length of your radius. So you might have to bend it, that's fine, bend it and then cut it. Okay? Fold it into fours so you can create your center. So fold it into fours to create your center and then draw a radius and then use your pipe cleaner to line up and basically show the length of your radius. We're going to construct or use an activity to discover radians. Okay, so make sure you have the piece that represents the length of your radius. Okay, so bend it if you need to, cut it off. I'm going to come by and pick up scraps and the extra piece of pipe cleaner that you have. Okay, kind of be mindful, make sure there's nothing around your desk. I'm going to be sweeping here in a bit. All right, so what I need you to do, you're going to take that piece off. Okay, you're going to take that piece off and you're going to line it up so that you're going to have to bend it a little bit. It is representing your arc, the curve of the circle. So you want it to bend it a little bit. You want it to be the curve because we're going to discover what exactly a radian is and hopefully see a relationship with that, with your circumference and your degrees. Now, a radian is very unique in the sense that the arc length here that you're going to line up on your circle is going to equal the length of your radius. Okay? So there's 2 animations we're going to look at to help you understand what you're going to end up creating. That's not the one. That's probably going to be at the end if we can get to it. All right, so here's this one.
Now, consider an arc length.
I don't know if it's that one.
The measure of the angles of an arc length in one radius is 1 radian.
Oops, sorry.
Equivalent to 1 radius. The measure of the angles of
So,
an arc length in 1 radius is 1 radian. We double the measure of the angles.
I went twice. Okay, so do you see how it's going to end up being on this curve here? Okay, what we're going to do is we're going to try to figure out how many radians we can fit in a circle. Okay? How many pieces? Huh? Close. You're so close. Yeah, you're close. What I want you to do, I'm going to have this playing. So, do me a favor. You have your piece lined up? You have it lined up on your circle? Put a tick mark to show where it ended, where it stopped. Okay? Put a little tick mark to show where it ended. Okay? And then, when you do that, go ahead and draw a line to create that radian, to create that piece. So once you've already done that tick mark, we're now going to create our pipe piece, our radian piece, okay? Because a radian piece is equivalent to the length of the radius. We have that. Use your protractor. Some people were using like a sheet of paper to create that straight edge. Okay, so you got one piece, right? Okay, so we're going to repeat that. We're now going to move our little piece that represents our radian to create another piece. So we're going to line it up to to the radius that we just drew. Okay? And we're going to make another piece. Okay? We're going to make another one. We're trying to figure out how many pieces, how many sections of radians would end up being on a circle. And then also, get close.
Wait, all the way around the circle?
All the way around the circle. So, what you're going to do, what we have up here is, let me find it real quick. There it is. No, it's this one. All right, so once you line up your edge, which it says wire, but it's the same thing as the pipe cleaner, you're going to repeat that, okay? So continue to do that. This is just a video of showing what they're creating, what you're going to create at your desk. All right, so start wrapping around your circumference to mark where it stops. Yeah. You need to use your pipe cleaner every time. Yeah, it's not going to be perfect. It won't be it's not going to be equal sections. Let's put it like that. Almost, yeah. All right. Once you get all the way around, write down the number of sections that you see. If you're using your pipe cleaner to create your radian every time, because it's an approximation here, let's see if we can determine how many sections you would have on a circle. Yep. You should have one little piece left over. Huh? You should have a little sliver left over. So every time, look how they're moving the pipe cleaner piece, and they make another tick mark, create another radian, draw another radius, all the way around the circle. Does it divide? No, that shouldn't happen, okay? If you did it correctly, it shouldn't be all equivalent. Okay? You mark it each time. Each time you move your piece, you add a tick mark, then add a radius. Uh-huh. Yep, leave your uneven piece. Yep. No, you leave it. Yeah, leave it there. Mm-hmm. Why is it doing that?
This video illustrates the definition of a radian. First, begin with a unit circle. Now,
So our sections, then we end up with a little sliver, a piece. Yes, okay, that's what you should have, like a little piece left over. Okay, go ahead and number your sections. Okay? And let's think about this. All right, we're going to start measuring in radians. We've been using degrees, okay? So let's think about this. If we're doing degrees and I'm doing a full circle, what's the degrees that represent the full? Okay, so what do you think a radian, one piece here, in degrees would be? It would be 60? Yeah, it would have to be a little bit less than 60 because we have this little sliver piece that's remaining, okay? So what we're going to do is we're going to try to convert from degrees to radians because a radian will give you a more accurate measurement when you're dealing with circles. Because if I asked you to cut, like if I did a smaller piece and I was to cut out my radian, it would still fit on your circle. Because a radian is always taking your radius to create that piece, okay? So what I want you to do is you're going to, here we go. So we're going to add basically our model of a radian. I need you to add, and I'll hit the lights. We're going to show that this one little piece is approximately 1 radian, okay? Because approximately how many radians fit in a circle? Yeah, 6 something, yeah, So we're going to, on page 4, glue this down. We're going to title it, what is a radian? We're going to add these notes, and we're going to also add definition, so you can leave some space underneath. I'll show you what it's going to look like, okay? Leave some space, because we're going to add some notes. Let me make sure it's on here. Yeah, there it is. Okay, so when you're ready, guys, make sure you have your definition. You have defined what a radian is. You have labeled it on your circle. We're adding the theta to show a piece. Now, you could put theta somewhere else if you wanted to put it here, but we're going to let that represent our 1 radian. Do we have this copied down? Okay. Mm-hmm. On bottom of the page or on the news page, okay? Couple things. If I was trying to find arc length, like the distance of that arc length, and let me get the right color. In this formula, to find the arc length in terms, okay, of radians, S represents the arc length. That was the length of this curve, okay? So R is your radius, okay? So this is our radius right here. And then times theta, which is our angle. That was our measure of the angle. Now, we're going to find what that measure of that angle is in terms of radius. So if I was doing a full revolution, like all the way around, how many degrees is that? All right, we got that. All right, so we have 360. Our length, our distance, all the way around represents, if I'm going all the way around a circle, what is that? That's the degrees. What's the length of that? I heard it, someone said. What is your distance going all the way around a circle? The circumference is your length of going all the way around a circle. Okay, so if I was gonna, let's say I was using the theta as 360. Let's say our degrees was the 1 revolution. Okay, so what I'm gonna do is I'm gonna substitute. Write this down either underneath your circle or on a new page. Let's use our circumference as our arc length, the full circle, 1 revolution. Okay, so that would be your 2 pi r. That's going to equal to our pi times theta. And in this situation, the angle is that 360 degrees. Okay? So we're going to figure out what theta is in terms of radians. So I can solve for basically our theta. can solve for that by just dividing both sides by the radius. Because your radius will cancel out, right? Which will leave you with 2 pi equal to your theta. And this is when we're talking about 360 degrees. So 360 degrees, okay, is 2 pi radians. So if I was doing 180 degrees, half of that would be, what would that be? Just pi. Yep, because we just divide the side by 2, right? So what we're going to do is we're going to use this relationship to create or to calculate radians as a measurement of length instead of as degrees. We're going to convert from degrees to radians. All right, those guys who need to leave, your time is here. All right, so if you need to put this extra example on another sheet of paper, you can. On the next sheet, I need you to copy down the proportion. Okay, this proportion can be used to convert from degrees to radians. So copy what's in the box at least, and we're going to do the example together. In the box, it's right here. Your degrees over 180 is equal to r radians over pi radians. Okay? Now you can start the proportion. Okay, so all right, guys. Here's what I need you to understand. There's two ways I'm going to abbreviate some things, but do you see how we have r radians over pi radians? Like, they're both radians, this word right here. Okay, oops, I don't know what I did. So, really what's happening here, we really can cancel that side out, and you're left with 45 degrees over 180, right, is the same as your r, which represents your radians, over pi. Y'all with me on that part? Okay, so all we're going to do to find the r, the radians, we're just going to cross multiply and solve for the r. Okay, so when we do that, we cross multiply, we get 45 pi equals 180 degrees r, 180 r. And now we're doing isolate for r, solve for r. So to do that, we're going to divide both sides by 180. Okay, we get the radians by itself, the r represents our radians, and then we're just simplifying this side. Basically simplifying 45 over 180. What does that reduce to? 1/4. Yeah, so we have 1/4 pi. We keep the pi. Because radians is in terms of pi. In terms of pi. So, our radian for 45 degrees, if I'm converting 45 degrees into radians, that is equivalent to 1/4 pi radians. And I'm just going to abbreviate that. 1/4 pi radians. Are we okay on that part? Now, here's what we're going to do. You're going to see a pattern. And you're going to realize you're going to do the same thing every time you're going to convert from degrees to radians. So, if you are ready, I want you to convert these degrees, and we're going to do some together, into radians. Okay? Because you can have, 390. So, let's do this. So, use our proportion. We have 390, the degrees, over what? 180 equals our radians. I'm going to do rad for radians. Over pi. There we go. Because 1 radian is going to represent a pi. All right, now we're going to cross multiply. Cross multiply. We get 390 pi equals 180 radians. And then we're solving for our radians, so we divide by 180. So our radians equivalent to 390 would be, when we simplify that, keep it improper. And then you keep pi in your answer. Always, when converting to radians, it's in terms of pi. All right, so let's do 54 degrees. Convert it to radians. 54 degrees over 180 degrees is equal to radian over pi. Anyone see a shortcut yet? What is it, promise? Okay, so this comes out to be 3 over 10. That's the answer? We're missing something. Yeah. Equals your radians. Okay. So 3/10 pi radians is the same as 54 degrees. What if I had 180? That would be 1 pi, right? What happens every time we're converting from degrees to radians? Did anyone see it? Because 45 degrees was 1/4 pi. Yeah. Yeah, so you just divide it by 180. Yeah, and just put the pi with it. Yeah, okay? So you're always dividing by 180. You just a fraction of 180 to get to that. All right, so I need you to add. Now, we're going to convert from degrees to radians, and then sometimes I'm going to ask you to go from radians to degrees. All right, so I need you to copy this down.